Okay, in part B, we're given this diagram. We're given three parallel lines and a load of different triangles. Whenever you see parallel lines, what I'd like to come into your head is some of the stuff we've studied in geometry. You should be thinking about corresponding angles, alternate angles, that kind of thing. Remember, in a diagram like this, there's bound to be vertically opposite, corresponding and alternate angles. That should be on your mind. In part A, we looked at similar triangles, so you should be thinking in that regard as well. To figure out where to begin here, we should look at the answer. I'm trying to prove that AH by QB equals AP by HB. The first thing I have to figure out is what triangles are relevant. For example here, the triangle KCR has obviously got nothing to do with it because none of those letters are here. But if I just look at my answer, I'll be able to figure out which triangles are relevant. In my answer, there's going to be an AH. So AH brings me from here to here. So obviously, like there's a few triangles that have that line in it, so I'm still not 100% sure. But it also has AP. AP is also in my answer, so this line is relevant. So if I need to get that distance and that distance, then obviously one of the triangles that I'm concerned with is the triangle HAP. That triangle contains the side AH and the side AP. Now let's look at the other ones with the B's in it. I also am concerned with QB, which is this distance, and HB, which is this distance. Again, there's only one possible triangle that could be relevant here. The other triangle that we need to concern ourselves with is the triangle HBQ. Now, these two triangles are similar triangles. So the next thing we're going to do is prove that the triangles are similar. Remember then, once we've proven the triangles are similar, that means their sides are proportional. It'll be easy enough then for us to get to here. But I think a big problem students tend to have is they just don't know where to start. That's how I would figure out that these are the two triangles I need, because they incorporate all of the sides that I need in my answer. In order to prove that two triangles are similar, I need to prove that they have two sets of equal angles. We don't need to bother proving the third set of angles, we just need to prove two of them. The easiest one I think you should recognize is that this angle and this angle are vertically opposite angles. So that's where we're going to start. So we should make this statement that the angle AHP is equal to the angle BHQ, and the justification is that they're vertically opposite angles. Now, the next one that we might look at is, again, when you're dealing with parallel lines, you should always be looking for alternate or corresponding angles. In this case, you should see that this one here and this one here are alternate angles. They form that familiar Z shape that you might have been taught that these are Z angles, but basically these two are also equal. So in this case, I've said the angle HAP, which is this one, is equal to the angle HBQ, which is this one, and the justification is that they're alternate angles. Now, because the two triangles have two sets of equal angles, we can then say that these two are equal to each other. Now, we actually could have used them in the proof because they're also alternate angles, but we don't need to bother. Once we've proven the two pairs of equal angles, we can now conclude that the triangles are similar. So I just conclude like this, therefore the triangle HAP and HBQ are similar. Now what I'm going to do next is I'm going to wipe off the diagram and just focus on the two triangles, because if I focus on the diagram now, it's going to get very messy. But essentially we're almost done. Now it's going to be very easy for us to make this conclusion. Once we've proven that the two triangles are similar, all that's left to do is to figure out which sides are proportional to each other. So the very first thing we did was we figured out that the angle here and the angle basically either side of the H are equal to each other. That was our first statement because they were vertically opposite. So I'm calling those angle number one. What I'm concerned with are the sides opposite those angles. That means, so the side opposite the angle in the triangle APH is the distance AP. The side opposite it in the other triangle is the distance BQ. So let's just leave that one there and figure out what other sides are relevant. The second thing that we did was we proved that the angle here at B, I'm going to call it angle 2, is equal to the angle here at A because those two were alternate angles. What I'm concerned with is the side opposite those angles. Opposite angle 2 in this triangle is HP. Opposite angle 2 in this triangle is HQ. Now, we didn't bother, but we could also say that this one and this one are equal to each other. The one at P and the one at Q are equal because they're alternate, and so the sides there are relevant. And obviously you can see in both triangles it's clearly the longer side. So opposite angle 3 in the big one, I'm going to put 3 marks at it. Opposite angle 3 in the small one, I'm going to put 3 marks at it. Now I can write all of these out in one equation. Let's look at the sides that have 1 dash. I'm going to take the 1 dash in this triangle and divide it by 1 dash in the smaller triangle. I can say that AP divided by BQ, notice in each case the sides that are opposite angle 1, is equal to, now I'm looking at the 2 dashes, on the big triangle it's HP divided by HQ. Both of those are opposite angle 2. The other 2 sides are the AH and the HB. Again, I'm using the big triangle on the top, so it's AH divided by HB. And now I obviously don't actually need all of this information. I would usually advise students to write out all 3 fractions, even though we only actually need 2 of them. Just look at your answer now and you'll notice that HP and HQ aren't in either of them, so it's not actually relevant. I've worked out that AP over BQ equals AH over HB. If I can essentially cross multiply here, or you could think of it as you're going to multiply both sides by BQ, so the BQ will go up here. Going to multiply both sides by HB, so the HB ends up here. And I simply end up with AP multiplied by HB is equal to AH multiplied by BQ. And you'll recognize now that that is the same as what we were asked to prove, so that's our final answer.